So for 5.5, we were talking about how to stretch functions vertically. And what it looks like when you stretch a function vertically would be like if you had a parabola. Well, if you stretched it vertically, then it's either going to become really narrow, or you could shrink it vertically and it's going to become really wide. So when you stretch or compress a function, you change the width of its graph. And if you want to stretch it vertically, then what it's going to be doing is it's going to be moving away from the x-axis. So you're stretching it and making it really tall, so it's getting farther and farther away from the x-axis. If you're compressing it, that means it's moving closer to the x-axis, that it's getting smaller and smaller and smaller, and you're shifting it down. Now, what happens to your equation when you do this is that you've been multiplying by something. So if you want to stretch it vertically, and these are actually backwards, I'm just going to let you know. If you're going to stretch it vertically, you're going to multiply the entire function by a number greater than 1. I want you to mark out the rest of that. So you're just going to multiply the entire function by something greater than 1. So the example they give you here is they started out with x squared, and they multiplied x squared by 3, and they got this function here that was narrower. And what it does is it's stretching it vertically. If you want to get something that's compressed vertically, that's something that's wider, then you want to multiply the entire function by a fraction that is greater than 0 and less than 1. So something between 0 and 1. So the example they use here is 1/3. So if you'll notice, compared to this x squared here, it's on our left, here's x squared. Well, when you did 1/3 x squared, this function became significantly wider. So what it did is it compressed it, it shrunk it, so it's making it a fatter graph. So when you flip the function over an axis, you change its points or coordinates on the xy plane. So when you flip something over the x-axis, then the y-coordinate switches signs. If you flip something over the y-axis, the x-coordinate is switching signs. But how does that change the equation? Well, if you're flipping it over the x-axis, that means you multiply the entire function by a negative. The entire function. But if you're just flipping it across the x-axis or the y-axis, then that means that you're going to multiply every x in the function by a negative. And I know you're probably thinking, well, isn't that the same thing? But it's really not. And we're going to look at some examples where you'll see that it really is different. For example, the one they give here. So they start off with x plus 4 cubed, which looks like this in blue. So this is x plus 4 cubed. Here, because I'm multiplying the entire function by a negative, that means I'm putting a negative in front of it, that means I have flipped it across the x-axis. So what used to look like this now looks like this. It's pointing the opposite direction. Well, this time, if you'll notice, I made the x negative in the parentheses, and so what used to look like this now is reflected the other direction, and it's on the other side of the x-axis. The y-axis. So you can see that putting the negative in different places does make a difference. So it says each graph shown below is either stretched, compressed, or shifted to form a new function. And we're supposed to use the graph in the description to write an equation for each g of x. So it tells me that x squared is stretched vertically, it's multiplied by 4, and shifted 1 unit down. So if it's stretched vertically, it's multiplied by a factor of 4. Well, that means I need to, for the function g of x, I need to multiply x squared by 4. And I shifted it down 1, so that means I need to subtract 1 on the end. It says x squared is compressed vertically, so it's multiplied by 0.5 and shifted 2 units to the left. So to write the function g of x, I've got to start with what I'm supposed to do first. It tells me I'm multiplying x squared by 0.5, so I need to put 0.5 in front of x squared. But notice I shifted it 2 units to the left, so that means that in parentheses, I have to put, instead of moving it to the left 2, so that means I need to add 2 to the x, and then my squared goes on the outside. So g of x equals 0.5, notice that is a 0.5 times x plus 2 squared. So looking at number 1, it says the graph of f of x is shown below. It resembles the graph of g of x equals x squared, but it's been changed. Which of the following could be the equation of f of x? Well, here was g of x, it opened up. F of x opened down. So that means when it's opened down, the function becomes negative. So it should be something to do with negative x squared. And if you look at what else happened, well, this graph was at 0, 0. This graph is at positive 2, so it was also shifted up 2 units. So we're looking for one that was shifted up and has a negative x squared, and that is going to be f of x. It equals a negative x squared plus 2. We're going to go ahead and do number 2, so you'll be responsible for number 3. It says the graph of f of x is shown below, resembles the graph of g of x equals x squared, but it's been changed somewhat. Which of the following could be the equation of f of x? So the first thing I notice is that it is pointing down, so that means it is going to have a negative x squared there. I'm also noticing that it was shifted over, and it looks like it was shifted to the left 3 units. So remember, a left shift of 3 means I need to add 3 to the x. And then it's supposed to be negative because I flipped it. So that means my answer would be the last one. F of x equals negative parentheses x plus 3 squared. So looking at number 5, says the graph of f of x shown below resembles the graph of g of x equals x cubed, but it's been changed somewhat. Which of the following could be the equation of f of x? Well, I'm noticing first of all that it went up 5 units. That's something that I can for sure tell, but there's a couple different options that have a plus 5 there. So I've got to decide it. We've got to figure out if it was reflected or if it was stretched. And this graph does appear to be narrower, so then we know it was stretched, so we should be multiplying by something. So if I start looking at my answer choices, because this time it may actually be easier to look at those to decide what it is. So it says f of x equals 4x cubed plus 5. Well, that would take care of moving it up 5, and the 4 in front would stretch it, so that's pretty good. Look at the next one. F of x equals negative 2x cubed plus 5. Well, the negative 2x cubed would mean that it would be going the other direction. The plus 5 is right, but that can't be right, so that one's out. 3x cubed minus 5, well, that would stretch it vertically. That's good. But the minus 5 would make it move down 5, which it didn't, so that's out. And then 3 parentheses x plus 5 cubed, that would mean that it would be moving left 5 units, and it didn't, so that one's out. So f of x equals 4x cubed plus 5 would be our correct answer. So number 7 says the graph of f of x is shown below. And it's trying to figure out how you got from g of x, which they tell you is x squared, to f of x. So g of x starts out at 0, 0, because it's our parent function, x squared. So it starts out at 0, 0, it goes through 1, 1, and negative 1, 1, and it's a parabola that looks like this. It doesn't look like it changed widths at all. It doesn't look like it got any narrower or wider, and we can look at our answer choices, and there's no numbers in front, so that we don't have to worry about. It just shifted left and right, so we've got to figure out and up or down. So we've got to figure out how much it shifted. So it looks like it went over 1, 2, 3, 4, so it shifted to the right 4, and then it went up 1, 2, 3, So if it went up 3, that means I need to add 3 on the end. If it went right 4, I need to minus 4 in the parentheses with x. And that would make my answer choice. The last one, f of x equals x minus 4 squared plus 3. 9 is a very similar problem. It starts out as g of x equals x cubed. And we're given f of x. We've got to figure out what happened. Well, I'm noticing that it's pointing the other direction. So it for sure had a flip. So I know I'm going to be doing something with negatives. And it also looks like it was shifted down because it was at 0, 0. Now it's at -2. So it went down 2, which means I'm going to be subtracting 2 on the end. So just starting there, if I'm subtracting 2 on the end, it's not the first one, it's not the last one. We also said we had to flip it, and so that meant it had to have some negative in front of x cubed. So f of x equals negative x cubed minus 2 must be our answer.